Welcome back to Maths with Miss S. This is part 1 on equations, and in this video we'll play around with a few number values. We know that 3 is 3, but we can also write out 3 as 2 plus 1, or minus 2 plus 5, or 7 minus 4. All of these would be true statements. Now let's try something. Let's add 4 on both sides. What would happen? Our statement would still be true. It's different number values, but the statement is true. It's still equal. Left side is equal to the right side. Let's now try and subtract something on both sides. Let's subtract 3 on both sides. So we have 3 minus 3 is 0 plus 4, which means only the 4 is left on the left hand side, and 7 minus 3 would also be 4. 4 equals 4. That is a true statement. Now, the whole purpose of an equation is that we usually try and find values, but the first rule is if you have a plus and you want to get rid of a plus value, a positive value, you subtract it. And if you have a negative value, you can add it on both sides to get rid of it or move it to the other side of the equation. Now let's look at this equation. A plus 3 is 7. We need to get rid of that plus 3, so we're going to try and subtract 3 on both sides, keeping this a true statement, and we get A is 4, and by feeding that back into the equation we can check that 7 equals 7 when we feed back for A is 4. Now we try 3 minus b equals 0. We bring the minus b over by plusing b on both sides, and we're left with 3 equals b. Again, we're going to check our answer by feeding that back in, and we get 0 is 0, which is a true statement. Now let's look at this equation. 3b plus 2 equals 4b minus 1. Now this time we have like terms, so b values on both sides of that equal signs. And we also have number values on both sides. Let's try and bring the number values on one side first. So we have plus 1 on both sides, which means we now have 3b plus 3 equals 4b. Now the 3b didn't originally have a plus. I added that in there. So if something does not have a sign, it is a positive value, meaning I will get rid of it by minusing it. So we minus the 3b on both sides, and we're left with b is 3. Now we feed back that 3 into our equation from the start, and we see that 11 is 11, which proves we